Uh, Great. Welcome to class again. Back to I hope you have enjoyed weekend. So anyway, today we're going to focus kind of. I'm going to brief whatever we covered this week. Then moving into the rotational dynamics. What is the rotational dynamic? What we need to what we have to understand the concept in order to understand the rotational dynamics. So let me share the file. So as you all know that, right, right. So in the last week we were focusing completely, and the one of the topic was like mechanics. Mechanics. We learned the actually like basic laws of mechanics, right? So what are the laws, the main laws to understand the mechanics? Mainly we were discussing about you know first initially like the what are the laws, basically first law, second law, third law, right? Then we applied those laws into conservation of momentum, conservation of energy, and what are the collisions theory, which could apply for the conservation of energy, momentum, right? So it's kind of like the basic stuff we have covered. First law, when you describe the first law, definitely we need to understand the inertia. When you we already discussed the what is inertia with examples, right? And the first law we don't discuss much about the force, right? Whereas the second and third law, we definitely there is a force come into the picture, right? So coming to the second law, second law always, whenever there is a momentum, whenever there is a force apply on the system, there would be definitely there is a motion. So like if you push an object, definitely it gets some velocity. So the object can get actually momentum. We call it like the momentum is a mass times velocity. So when the momentum changes with respect to t, we call it as a like what do you call it? It's a force. So especially we have discussed the force definition, right? So force is the is a physical parameter which play very important role in mechanics. The in mechanics actually without force we always discuss the like kinetic theory of kinematics basically where the force doesn't play. So you can think about mechanics basically broadly like divided into two parts. One is actually kinematics where there is no importance of force. Okay, and there is a one more thing called dynamics. When I say kinematics and dynamic definitely there would be a force. I mean, dynamic itself you can think about the force, right? Kinematic is the one of the you not subunit where force is zero, right? Here force is not equal to zero. And we here we always discuss about the Newton's laws, where the system gets motion, where the system gets the momentum, etc. In case of kinematics, the kinematic here we mostly focus on the freely falling bodies. Suppose you just release the object from the flight, you just release the object from the building. We call this is like freely falling bodies, where you don't apply the force, right? But when you apply the force, even upward, I mean, in the even in the case of vertically projected upward case, in this case also we consider f is equal to 0, downwards or upward. So this is vertically projected upward bodies and this is freely falling bodies. In these two cases, we don't consider force, and this is kind of like a kinematics. We mostly discuss in the school level, intermediate level. But when you come into the dynamics, mostly this is the one of the major topic, the main topic to understand the mechanics. See, when I want to talk about mechanics, what is mechanics? I told you, right? Mechanics is just not a motion, but whatever your muscle is moving. So suppose you are doing some kind of physical exercise in the morning. So definitely there is a muscle movement between the one muscle, right? There's a motion, relative motion with the muscles. when you're bending, when you're walking, everywhere, like there is a kind of like, motion, there is kind of like a friction between the muscle cells, etc. So that is also mechanics. Mechanics is not, don't think about just simple mechanics. So mechanics play a very important role in all areas of science and engineering. Like, when you got a surgery, definitely mechanics play, because you are doing cutting, you cut the tissue, right? When you cut the tissue, it feels so much forcible, right? You apply some kind of, you cut with the scissor, right, and take out the baby out. I mean, there are a lot of surgery when you get a heart, brain surgeries, lot of surgeries. Definitely there is a dynamic is going on, right? So uh, in that case, basically, completely force play very, very important role. And moving into the, as I mentioned, a major topic is like, dynamic. Okay, dynamic effect not equal to zero. So here we just discussed the Newton's first law, second law, and third law. Third law definitely, one thing you have to, second law definitely it's simple, dp by dt, right? So rate of change of momentum, right? So when there is a force, there is a rate of change of momentum. When there is a momentum changes, there is a force. So vice versa, this is right. And Newton third law, what are these actually? Action, reaction, and reaction force, right? And these two, they do not apply on the same surface. Remember this. So they are pair, action reaction are the pair which are actually equal and opposite term, right? But they do not apply on the same surface. And this force apply on the this surface, and this force apply on the other opposite surface. So they do not apply the same surface. So that is important point to remember. And coming to the momentum, suppose let us say my external force equal to zero. In the case of rocket, what will happen? There's a booster, I told you, right? So in the external force, initially you apply some kind of force, then if external force is zero, still rocket goes in forward direction, right? If external force equal to zero, dp by dt equal to zero. If this is equal to zero, dp is equal to zero. If dp change in, this is what is dp? Change in momentum, change in linear momentum. In that case, this is constant, because dp means it's a final minus initial equal to 0, and p1 is equal to p2, which is basically p. So momentum is same. If the momentum is same only when the external force equal to 0, in that case we call it conservation of momentum, conservation of momentum, right? So when there is a conservation of energy also there. Suppose if you take the two balls and they collide and they separated after the collision. In this case, kinetic energy of the initial system, kinetic energy of the system before collision must be equal to kinetic energy of the system after collision. If these two are same, we call it energies conserved. And we also discussed the two type of collisions: elastic collision, inelastic collision. Elastic collision, you all know that definitely elastic collision, what happened? Both are conserved. Momentum and energies are conserved. Both quantities are conserved. Conserved means anybody knows? Does not change. What is a conservation mean? It doesn't change. It remains same, right? So momentum, the collision in which momentum and kinetic energy are conserved, we call it an elastic collision. Only momentum is conserved because in elastic collision. This is what you have to, we have summarized. I mean, I just want to summarize the things. Then we also did a rocket motion. In this case, remember that what is the importance concept? Variable mass. Variable mass, here we are changing the mass into mass changing m plus d delta m, or m plus dm. And velocity also changing, it's not constant, v plus dt. So this is what we have considered here, right? And with which we have completed the rocket motion equation, right? And this is what we have discussed. We took this, and finally, change in momentum we have substituted here, external force equal to this, right? Then finally what happened? We took that external force equal to 0, then we got our equation for the thrust, right? Rocket definitely can accelerate even no external force act on it. So momentum is conserved. And we have also discussed the multi-stage rocket. So what is a multi-stage? And a multi-stage, definitely it's a very important thing that you have to remember. There are various stages in the rocket. The one is actually booster. Booster is the one which basically helps to launch the vehicle. So here initially you apply the force, there is a strap on boosters. Booster can be reusable. Booster can be reusable for again and again. So startup boosters we call it. So startup booster definitely reusable to for next satellite too. And it has actually what are there? It's a liquid. So what is the strap? This has a 4 liquid strap and motor. So this is actually reusable to again. So first step you have to remember for in case of satellite, JSLV, any satellite, booster is the first step. Then the first step is there. So there is ignition happen, fire will come, right? Continuously after 4 seconds. And here what we have here is the again the solid, there is a solid core is there. So in the firstly there is a booster in downward, and there is the next stage is the first stage where you have the solid material as a fuel. Then the second stage, then the third stage payload pairing. This is the stage where it goes into the orbits. Okay. So these things also important. You have to remember it. So we have also discussed this, very important. What are the advantages and disadvantages of multi-stage rocket? So a special main advantage of the multi-stage rocket is we can minimize the weight of rocket. If you make the single rockets, you need same booster and everything. But if you make the multiple rockets, why we need multi-stage rockets? Because we want to know the various information about the earth through, right? When the rocket when the satellite rotate around the earth, it gives the broadcasting information, communication technology, signals, etc. So if you keep the multiple rockets in a single one, so you get a lot of information. So basically from here, from that, what you can do, you can minimize the weight. And this one already we done that conservation of momentum, force is no zero. I mean, we have proved this also. So 1D collisions, when I say different type of collisions means 1D, 2D, 3D. So 1D collisions, if the collisions happen in a single line, we call it as a 1D collision, right? So we consider in this case only one axis, X, Y, Z, any one axis, right? 1D means you have to focus only one direction. So the bodies will collide only single direction. Then moving into the 2D dimension. So 2D dimensions where you have the two objects collide, but then they have a two directional, right? So when you are considering the 2D, basically, here this is still 1D, but moving into the 2D, 2D means you have the two components, X component, Y component. So each velocity divided into two components. So 2D dimension, you can see that here example is there, so it moves into two direction. When you hit that point, it move into two direction. Right. I mean, you can see here equation 2D dimension collisions, X direction, Y direction. You have a two equations, right? So if you solve this equation, you're going to get velocity of objects. So moving into the, 3D also similarly, you can also discuss the 3D, right? Where you have the X, Y, Z. Okay. Then, so I want to go for the whiteboard. I want to share now to whiteboard. Rotational dynamic. So this was actually why okay, let me stop sharing first, then moving into the whiteboard. So yes, here, right. So now the question, what do you want to do? Like whatever I just covered the summary, I hope it helped a little bit. Now the question is rotational dynamics. Dynamics, rotational dynamics. Normal dynamics and rotational dynamics beta. Rotational dynamics. So what is this actually? What is rotational dynamics? Anybody would like to share your ideas? Anybody? Can I ask or do you want to share it? Can I ask? I guess I want to find. Okay, Shirisha, do you want to share something about rotational dynamics? Shirisha, are you there? Do you want to talk about at least what is rotational dynamics? Just you can share. Rotational means what? What we discuss in rotational dynamics. In intermediate, you have completed like a rotational motion, right? Or anyone, please, you can mute. If you don't, it's okay. Don't waste time. Aishwarya?
Yes, sir.
Do you want to share anything about rotational dynamics? Rakesh? If you don't know, just say no, I don't know, sir. Don't waste my time. Rakesh? Rakesh Yadav?
Don't know, sir.
Don't know? Madhu? Madhu, are you from Madugula or surname is Madugula?
Surname is Madugula, sir.
Okay. So you are from?
Bongiri, sir. Yadadri Bone.
నానా చెప్పు కొంచెం అంటే రొటేషనల్ డైనమిక్స్ అంటే మనం ఇంటర్మీడియట్ నేర్చుకున్నాం కదా.
No idea, sir.
No idea. Naveen, Mudraj. ఆంజనేయులు.
సార్
గుడ్ మార్నింగ్ అన్న. ఏమన్నా షేర్ చేసుకుంటావు బేటా?
చేసుకుంటాను సార్.
చెప్పు నాన్న. వెరీ గుడ్. ఆంజనేయులు
సార్
చెప్తావా ఏమన్నా?
సార్ వస్తలేదు సార్.
రావట్లేదా? ఓకే నాన్న, వెరీ గుడ్. సూర్యతేజ
సార్
చెప్తావా? సూర్యతేజ రొటేషనల్ డైనమిక్స్ అంటే
సార్
రొటేషనల్ డైనమిక్స్ అంటే చెప్తావా నాన్న? లేదా Nana, you can change your names here. Somebody is saying like no box. I cannot see the names here, right? Should write your full name beta. Galaxy J2, not like that. You should change your name. It is a possible. There is a, you just click on your name and change it. Pooja?
Yes, sir.
చెప్తావా నాన్న?
Don't know, sir.
మా మీరు అందరు ఇంటర్మీడియట్ చదివచ్చారు కదా. అసలు నేను చెప్పేది ఎక్కుతుందా బుర్రలకి ఏమన్నా ఇప్పుడు?
Yes, sir.
అంటే ఇంటర్మీడియట్ పాస్ అయ్యే ఉంటుంది కదా మీరు అందరూ. చెప్పు ఉపేందర్, చెప్తున్నావా?
Dynamics is concerned with force and mass, their effects motion.
రైట్. ఓకే. రొటేషనల్ అనే వర్డ్ నుంచి మనం మాట్లాడుతున్నాం ఉపేందర్. రొటేషనల్ డైనమిక్స్, సపోజ్ రొటేషనల్ డైనమిక్ అంటే రొటేషనల్ అవ్వాలి ఆబ్జెక్ట్. ఎలక్ట్రాన్ న్యూక్లియస్ చుట్టూ తిరగడం కానీ, ఫ్యాన్ తిరగడం కానీ, ఇలాంటివన్నీ కూడా రొటేషనల్ డైనమిక్ ఎగ్జాంపుల్. There is a very important physical parameter which we indicate with torque. What is torque? Torque definition, force definition is dP by dt, right? What is the definition? What is the equation for torque? That gives everything. Anybody know torque definition? Torque, what is torque?
టర్నింగ్ ఎఫెక్ట్ సార్.
Okay, very good. అంటే దాని అర్థమైందని ఇక్కడ టర్నింగ్ ఎఫెక్ట్ అంటే
R cross F, sir. R cross F.
ఆర్ క్రాస్ ఎఫ్. దీని మీనింగ్ ఏంటి చెప్పండి? ఆర్ క్రాస్ ఎఫ్ అంటే సపోజ్ ఎట్లా డిఫైన్ చేస్తాం అంటే ఇప్పుడు ఇది రేడియస్ అన్న ఆర్ వెక్టర్ రేడియస్, ఫోర్స్ ఆర్ క్రాస్ ఎఫ్. ఇది ఎట్లా డిఫైన్ చేయాలి నేను? ఆర్ క్రాస్ ఎఫ్ ఎలా ఈ ప్రోడక్ట్ క్రాస్ ప్రోడక్ట్ అనేది ఎప్పుడు కూడా రొటేషన్ ఇస్తుంది, టర్నింగ్ ఇస్తుంది. అంటే ప్రతి ఇట్ చేంజెస్ ఎవ్రీ యాంగిల్, రైట్? థీటా చేంజ్ అవుతా ఉంటుందా? ఇది యాంగిల్ చేంజ్ అవుతూనే ఉంటుంది కదా, ఎప్పుడు రొటేషన్ అవుతుంటే. when angle changes, cross product means it always changes the angle. RF sin theta, right? Torque is equal to RF
sin theta.
So when theta changes, torque also changes, right? Is it clear?
Sir.
So now when I say rotational dynamic, RD, so rotational dynamic, mainly torque is the one which play very important role first, right? So torque, turning effect of object, turning effect is called torque. Somebody said, actually, that's good. And there is one more thing, actually, dl by dt. What is this? Like dp by dt, we write it in a linear motion, like f is equal to, what is this? dp by dt. But torque is equal to also, we call dl by dt. What is L actually? L? What is this? Anybody know? What is P here? P is linear momentum, right?
Yes, sir.
P is linear momentum. L is actually angular momentum, right? Because angle is changing, angular momentum. So P is linear momentum, angular momentum. So this is kind of similar actually. See, this is a linear motion. We call it like a dp by dt. This is a rotational motion. So when the object is rotating, we consider torque. Okay. So when you apply a force in this direction, the object also goes in this direction. So when you apply force here, it can get velocity and momentum also changes, mv, right? As you change the force, momentum can change. Here also, as you change the torque, angular momentum also changes. So mainly dl by dt. What is dl here? Angular momentum. So one question I would like to share with you. When electron is revolving around the nucleus, suppose this is the electron. So it's revolving around the electron. So around the nucleus, right? So the question I'm going to ask you, if it revolves around the nucleus in a particular orbit, why it doesn't collapse into the nucleus? So as you know that, everybody knows that electrons are revolving around the nucleus in cheptunnam kada. If it revolves, it loses energy and it collapses into the nucleus kada. Mari ala jaragadu kada, general ga nucleus lo collapse avatle kada. What is the reason? Ippudu electron nucleus lo padakapodaniki reason enti? As you all know that, if I ask someone, you to run the 10 kilometers, after that what he does, he loses his energy and collapse. మీరు 10 kilometers నడిచిన తర్వాత ఎనర్జీ మొత్తం అయిపోయి కింద పడిపోతారు. But electron, it doesn't collapse. It just keep on rotating, keep on revolving around the nucleus. So what is playing important role here? What physical parameter? Anybody knows here? ఎవరికైనా తెలుసా నాన్న? అంటే న్యూక్లియస్ చుట్టూ తిరుగుతున్న ఎలక్ట్రాన్ న్యూక్లియస్ లో ఎందుకు పడిపోదు? ఎనీబడి టాలెంట్ చూపించాలా బేట? మీ టాలెంట్
సార్ మళ్ళీ ఒకసారి అడగరా?
ఇప్పుడు ఉన్న ఎలక్ట్రాన్ బేట, ఇప్పుడు నేను ఏమంటున్నా, ఇది న్యూక్లియస్,
ఎందుకు
ఇది ఎలక్ట్రాన్, తిరుగుతూనే ఉంటుంది కదా, ఆర్బిట్స్ ఉంటాయి ఇక్కడ. కానీ న్యూక్లియస్, ఇక్కడ న్యూక్లియస్ పాజిటివ్ చార్జ్, ఎలక్ట్రాన్ నెగటివ్ కదా. జనరల్లీ ప్లస్ మైనస్ ఆల్వేస్ అట్రాక్ట్ ఈచ్ అదర్ అండ్ ఫార్మ్ ఎట్ డైపోల్ కదా. బట్ ఇక్కడ ఏమవుతుందంటే ఎలక్ట్రాన్ నెగటివ్ కదా, న్యూక్లియస్ లో ఉన్న ప్రోటాన్ పాజిటివ్, రైట్? దే షుడ్ అట్రాక్ట్ అండ్ ఎలక్ట్రాన్ షుడ్ కొలాప్స్ ఇంటూ ది న్యూక్లియస్, రైట్? కానీ అలా జరిగితే మనకు మ్యాటరే ఉండదు. నో మ్యాటర్, నో స్పేస్, నథింగ్. ఆటం అనేదే ఉండదు,
ఏది ఉండదు సరిగా.
మరి ఏంది, ఎగ్జిస్టెన్సే ఉండదు మనకు. సో మరి ఎందుకు కొలాప్స్ అవ్వట్లేదు? వాట్ ఈస్ ద రీజన్ బిహైండ్ ఇట్?
సెంట్రిఫ్యూగల్ ఫోర్స్.
ఇక్కడ సెంట్రిఫ్యూగల్ ఫోర్సెస్ పెద్దగా అంత పనిచేయవు న్యూక్లియస్ లో. మనం ఎక్కడున్నాం చెప్పండి? 10⁻⁻10 కానీ 10⁻⁻15 రేంజ్ లో ఉన్నాం.
స్టెబిలిటీ.
ఈ 10⁻⁻10 అనేది ఇది ఏమవుతుంది? డయామీటర్, ఐ గెస్ ఆటమ్ సైజ్. ఇదేమో రేడియస్. సో ఈ రేంజ్ లో అవి సెంట్రిఫ్యూగల్ ఫోర్సెస్ పెద్దగా ఇన్ఫ్లుయెన్స్ చేయలేము. అంటే నానో లెవెల్లో ఉన్నాం మనం, నానో పైన. సో ఇట్స్ వెరీ స్మాల్ సైజ్. I can give the clue. Bohr atomic model can explain this. Bohr model ఉంది కదా, Bohr postulation.
Sir, kinetic energy, sir.
Kinetic energy చెప్పనా? చెప్పాలా? కైనెటిక్ ఎనర్జీ ఎలా? ఇప్పుడు అది పడిపోవట్లేదు కదా. ఎందుకు?
ఆర్బిట్ లో ఉంటుంది కదా సార్.
ఆర్బిట్ లో ఉంటే ఇక్కడ మనం బాగా గుంజేస్తున్నా కదా, పాజిటివ్ గా ఉంది. మీకు అందరికీ తెలుసు పాజిటివ్ చాలా ఎక్కువ, న్యూక్లియస్ లో చాలా ఎక్కువ ఉంటుంది. ఎలక్ట్రానే లైటర్, చాలా బలవంగా గుంజేయచ్చు ఎలక్ట్రాన్ లోపలికి. ప్లస్ ఇంకొకటి ఏంటంటే ఎలక్ట్రాన్ తిరుగుతూనే ఉంటది కాబట్టి ఎనర్జీ కూడా లూజ్ అవుతుంది కదా.
అది ఆర్బిట్ లో ఉంటుంది సార్. ఆర్బిట్ లో ఉన్నంత వరకు దానికి ఎనర్జీ వస్తూనే ఉంటది కదా సార్.
ఎనర్జీ వస్తుందా మారదా?
మారదు సార్.
సేమ్ ఎనర్జీ ఉంటది. సారీ, సేమ్ ఎనర్జీ ఉంటది సార్. అది ఆర్బిట్ ఉన్నంత వరకు సేమ్ ఎనర్జీ ఉంటది.
ఎవరో మ్యూట్ చేయాలన్న. ఎవరన్నా ఇందాక చెప్పింది?
నేనే సార్.
పేరు టెల్ మీ యువర్ నేమ్.
సంజయ్ సార్.
విజయ?
సంజయ్ సార్, సంజయ్.
సంజయ్. సో వేర్ ఆర్ యూ ఫ్రమ్?
ఐఎమ్ ఫ్రమ్ సికింద్రాబాద్ సార్.
Okay, native from, you are from Secunderabad or somewhere?
Mahabubabad sir, Mahabubabad, Warangal దగ్గర.
Okay, very good. Yeah, very good analysis. See, whenever ఇప్పుడు సపోజ్ మన రాకెట్ కూడా పరిస్థితి అదే. రాకెట్ ఏం చేస్తాం? ఫస్ట్ సాటిలైట్ ఏం చేస్తాము? సాటిలైట్ ని తీసుకెళ్లి ఆర్బిట్ లోకి పెట్టేస్తాం. ఫస్ట్ ఎర్త్ చుట్టూ తిరగడానికి ఆర్బిట్లకు పంపించేస్తాం. ముందు ఇక్కడ నుంచి ఎర్త్ పై నుంచి సాటిలైట్ ఏం చేస్తాము? ఆర్బిట్ లో పెట్టేస్తాం. ఆర్బిట్కి వెళ్ళేంత వరకు మనకు దానికి కావాల్సిన ఫ్యూయల్ మొత్తం ఇస్తాము. వన్స్ ఇట్ రీచెస్ ఇన్ ద ఆర్బిట్, దెన్ ఇట్ డజంట్ లూజ్ ఎనర్జీ. కంటిన్యూస్ గా తిరుగుతూనే ఉంటుంది. దానికి 10 ఏళ్ళ 20 ఏళ్ళ ఎంత టైం ఇస్తాము, అప్పటిదాకా తిరుగుతూనే ఉంటుంది. సో అక్కడ ఎనర్జీ ఏంటి? కాన్స్టెంట్. అక్కడ అంటే రిమైన్, ఇట్ డజంట్ చేంజ్. ఓకేనా? సో ఇక్కడ కూడా అంతే. When electron is revolving around the nucleus in a particular orbit or stationary orbit, it doesn't, neither it loses nor it gains. So it just simply energy is constant. Kabatti even though there is a force from the electrostatic force, ante untunnappadiki there is a force from the nucleus or proton, that force does not actually dominate. Right? So whatever the energy or momentum is conserved in that particular orbit, so it doesn't lose energy, it doesn't gain energy, so it doesn't even collapse into the nucleus. So the main reason is conservation of angular momentum. You have to tell actually. It doesn't lose energy, it doesn't, even the momentum also it doesn't change. Continuously orbit లో తిరుగుతూనే ఉంటుంది. అంటే ఆ కంటిన్యూస్ తిరుగుతూనే ఉంది కాబట్టి దాన్ని ఏమంటాం మనము యాంగులర్ మొమెంటం కాన్స్టెంట్ అంటాం. That means what is that? Torque is equal to dl by dt. If the torque is zero, because once it reaches the orbits, this is equal to zero. Torque zero. You don't need to apply any torque. So in that case, dl is equal to zero. So L2 minus L1 is equal to zero. So L1 is equal to L2 is equal to L. So angular momentum is conserve అవుతుంది. Angular momentum conserve అవుతుంది. That is what. So అర్థమైంది ఈ క్వశ్చన్ ఆన్సర్?
Yes, sir.
సో ఎందుకు కొలాప్స్ అవ్వదో అర్థమైంది. అంటే దిస్ ఈస్ ద బేసిక్స్ నాన్న. అంటే రొటేషనల్ డైనమిక్స్ కి యూ నీడ్ టు అండర్స్టాండ్ వాట్ ఈస్ ద యాంగులర్ మొమెంటం, what is the what is the angular momentum, and what physical parameter helpful to rotate an object. So angular momentum is the main factor. Of course torque is the main one. Torque and angular momentum related, so torque play very important role. So torque is equal to dl by dt. Don't write Uday. Are you Uday? Don't write it. This is not for you, right? So torque, angular momentum, energy, all these are very important in rotational dynamics. So if the fan is rotating, the electron is revolving on the nucleus, if Earth is moving around the sun, all these are the what is going on. Definitely, this is mainly conservation of angular momentum. So that torque play very important role. So you have to understand this. Don't keep quiet when someone asks you what is rotational dynamics. Rotational dynamics is the dynamic where you have the torque play very important role, right? If the torque equal to zero, angular momentum is conserved. So here we discuss mostly rotation of the objects, how the rotation happening, what are the factors which lead to the rotation of the motion. So all this we discuss it. And moment of inertia is a very important in this. Moment of inertia. What is inertia? We already discussed. Moment of inertia is very, very important. So I have a class, I think final year. So I just want to, I think final years, I don't know, they didn't even join it. But anyway, so yeah, just this today, it's kind of like introduction. So I'm going to complete the remaining topic in the part B of the unit 2 this week. Okay. So after that, once we complete this unit, almost like a 50% syllabus is over. So most probably I'll complete today, this week, this completely part B unit. After this, we have to think about exams. I'll take some break because of the, I have to make you read all these two units. I'll keep kind of exams. So after that, 1 week break. After 2 years, I'll take 1 week break. Then again, we'll start the unit 3. Okay. So yeah, any doubts? Any doubts, Nana?
No, sir.
Oh, did I send you link today? Attendance.
No, sir.
But you're not asking anything. How should I know? Tell me. It's very important, right? It is also very important. Right. I'm just posting the attendance beta. Yeah, I just posted attendance. Please complete it. Did you receive it? Yeah.
Yes, sir.
Okay, please finish it. Okay. Right.
Okay, sir.
Right. Right. Thank you. Thank you so much. Have a wonderful day. Do you have a class now?
Thank you, sir.
Do you have a class?
Yes, sir. Maths class.
Okay, then. Okay, great. Right. You can leave it.